Okay, we're live on YouTube.
Hello, everyone. Welcome to another edition of Ferrilli YouTube Live. Today, we're going to talk about stored computed columns. And it occurred to me when I was reviewing my slideshow that I did not at any point define what a stored computed column is. So I thought I'd do that right now before we get into the slideshow. And it's one of my favorite oxymorons of all time, a stored computed column. So this is data that is normally calculated, but we're going to store it instead. So that's the definition of a stored computed column, data that we normally calculate because the data changes. And GPA is a great example. All right, GPA is great for a certain period of time, but then as more credits roll in and grades roll in, that GPA changes. So that's why we don't store the GPA, because it changes. Stored computed columns allow us to store that GPA and recalculate it when needed. All right, so let's get into the slideshow. Let me share my screen. All right, stored computed columns. So we're going to talk about what the problem is that I'm trying to resolve with this stored computed column. A little discussion about, like, gosh, is it really worth the effort to create a stored computed column and everything that goes into that? Is there another way that I could resolve this problem? And then get into all the steps for creating a stored computed column and putting that into place. So what is the problem that I'm trying to resolve? Well, there was a query that was just taking a long time to run in an SQL environment. So, 25 to 30 minutes for a query. So I researched the query. It uses a series of computed columns to some credits based on, a set of criteria. I tried rewriting that computed column so it didn't use as many computed columns. I tried writing a custom IS subroutine to hopefully simplify the process. And the best execution time I got was 20 minutes. So that is a long time for a query to run. So my resolution was to do a stored computed column. So the is it worth the effort piece, I considered two methods to try and speed up this query. Stored computed column, obviously one, and then TSQL is another possibility. I'm going to save that for a later Tech Talk Tuesday session. I'm not going to go into that here. Is it worth the effort? So creating a stored computed column does take some development time. There may be a quicker method. You could improve the efficiency of the query, divide the query into separate selections, target the criteria that reduces the most number of records, target that to execute first, so that when you get down to evaluating the computed columns, there's less records to do that on. Rewriting the computed column using an IS subroutine, as I talked about, those are all methods that you might want to try before diving into the stored computed column. Finally, you're creating new software on the system, so that is going to need to be managed somehow and put into the to the management queue. Just a consideration, right? In this case, the math is pretty straightforward. If it takes me 3 hours to get this whole stored computed column thing up and running, that's 9 executions on the best day for that original query. So that's an easy case to make. All right, here are the steps to create and implement a stored computed column. The first thing you need to do is create a custom stored computed column peer entity. Peer entity is a co-file of an existing colleague file. So we're going to create a co-file for this stored computed column. We need to create a wrapper subroutine. I'll talk more about that later. We need to identify the attribute as a calculation. So we're going to put attributes in that peer entity that we're creating. And one of those attributes we're going to define as a calculation. And then finally, we need to update that stored computed column peer entity. So I'm going to take this slideshow, step 1, 2, 3, and 4, and hopefully that'll give you everything you need to create your own stored computed columns. So in creating this custom peer entity, I need to kind of know what the original intent of the query is, because that's going to dictate what colleague file I'm going to create this peer entity from. So it was a fairly straightforward query, selecting on the delivered person st file with this computed column x.pst.sum.creds greater than or equal to some amount. That computed column uses other computed columns to essentially go out to the student ACAD cred file, grab all the credits that meet a certain criteria, bring those back, and then sum those up. And that's what you get in x.pst.sum.creds. So I'm going to create a custom co-file, a peer entity to person st, because that's where my original selection was coming off of, was of person st. I'm going to call my stored computed column entity f99.person.st.cc. So the CC is an extension that's suggested. It's not required, but it's a good way to identify, oh, here's one of those files that's got stored computed columns in it, as opposed to, say, the students file, which is loaded with student information. This is kind of a special file. And then, F99, just a placeholder for your client ID. I know lots of folks use an X dot, which would be totally fine. The idea is to identify it as custom and then identify which existing colleague file this is a peer entity of. All right, so we have to use Colleague Studio to create that stored computed column peer entity. I'm just going to take a look at an existing delivered peer entity that's used as a stored computed column. This one is Stu ACAD levels, and you can see that this sta.store.cum.gpa, one of the ones I was talking about, it's storing a GPA. We've got the exact same field name with the prefix of _F. That's a flag field, and I'm going to tell you how that field works. This is a requirement for stored computed columns, that the name of the flag field is exactly the same name as the stored computed column with the prefix _F for flag field. All right, now we're going to get into Colleague Studio and create that stored computed column peer entity. Already know what the name is, so I plug that in. The application, you just want to make sure you set that to where the data that you're going to need to make the calculation resides. So it would not work to make for me to have this be the core application, because I don't have access to any of the student information that I need to make the calculation. We hit finish after making sure dynamic allocation is set. and we have our overview page in Colleague Studio, put a little documentation in there. All this other stuff is pretty much the same for any other custom file that you might create. I did put in the peer entity of person ST, more for documentation, kind of double dosing it here in the purpose and in the peer entities. All right, so the file shell is created. Now we're going to add some attributes. And since this is a co-file of person ST, I took a look at the person ST ID attribute because I want to make sure my key attribute for my file has the same default settings. The important ones are the, to make sure match, are the internal size, the whether zero padding is checked or not, and whatever conversion string should match or be consistent. This other stuff, not quite as big a deal. Like for example, justification on person st.id is set to left. I set it to right because when I when I was coming up on all this stuff, the way I remembered whether to right or left justify was left is for letters, right is for arithmetic. And so if the data is numeric, that's, and you can do, you know, arithmetic on it, it should be right justified. So that's why I put that one in there. But my internal size is the same. I'm not zero padding either one, and I don't have a conversion string. Those are the three big ones. All right, key piece is done. Now we're going to create the the data element. I just named this F99 PSTSCC, person ST, store computed column, some creds. I fill out my attributes page. And again, here's where I want to be consistent with how a delivered field holding the same type of data does things. So again, the internal size is the same, 9 and 9. I've got a slight change to my conversion type as opposed to what is listed on stc.cred. They included a comma. I did not include a comma. So if the cred, the sum of the creds is over 1,000, I will not have a comma delimiting the 1,000 mark. That's the only difference. But otherwise, they are very consistent. So I've got my stored computed column data element. Now I'm going to create the, oh gosh, I totally forgot about this. I would consider adding in the entity name, add date, add operator, change date, change operator to your peer entity. It's a nice feature to have, and those fields automatically update. You don't have to do any special stuff. Those will automatically update with the appropriate information. So I just wanted to put that in. Also, that's the reason to not have your file name, your peer entity file name, longer than 20 characters. Because if you create these fields, you'll need 8 characters to do that, and the maximum length of a field name can't exceed 28 characters. So, all right, flag field. This is pretty straightforward because it's the exact same name as the field you created, as the data element you created, with the addition of the underscore F at the end. And this is a flag field, so, you know, display size can be 3, internal size is going to be 1. It's just going to be holding a yes or a no. And the output mask, the output mask, that is incorrect. I should not do a mask there. I should do output editing. So, oof, love YouTube Live, because that's a mistake. It would not affect processing it would affect if you're displaying. So this is not going to crash it at all, but you should not have a $YN on your output mask. You should have a $YN on your output hook, which would be, you know, one of these two remaining hooks up here. Love YouTube Live. That's fantastic. And I reviewed this session a lot before giving it. All right, so when it's all done, your stored compute column peer entity will have a key to an existing colleague file, same as person ST in this case. You'll have the data element that's going to store the information, and then you're going to have the flag field. And then if you did any of the add date, add operator, change date, change operator stuff. All right, that's step one. You've created the custom stored computed column peer entity. Now you need to create a wrapper subroutine. And I just want you to do the shell of the wrapper subroutine at this point. Things that make up a wrapper subroutine, Ellucian delivers a number of them. They will all be suffixed with .ws for wrapper subroutine. Wrapper subroutines always have 3 entry arguments, and they are named in some variation the return result, AL names, and AL values. So I want you to create your own custom wrapper subroutine for use in this stored computed column. So you'll need to fill out really just the overview page, which has all the standard stuff, and your 3 entry arguments, A.result, AL names, AL values, the overview page. And then you need to fill out the code page. You don't have to write any code at this point. Just put your documentation. Matter of fact, if you just want to put a single asterisk on the code page, that would be fine. I filled out all the documentation for it. But you'll want to generate what you have so far. And I know it's just shell. We're going to come back to this and actually write the code a little bit later. But I need a generated subroutine, wrapper subroutine for use later. Okay, that's it. Wrapper subroutine, super easy at this point. Now we need to identify that attribute in our stored computed column peer entity as a calculation. So I go back to the attributes. I right click on my attribute that's going to store the sum of the credits, and I'll get a list, and I can choose to make this a stored computed column. Now, when I select that, it's going to kick off a series of forms that you need to fill out, which I'm going to go through next. The first one that you are presented with is the identifying the trigger attributes. And you can see that there's a place you can add trigger attributes. Now, what is a trigger attribute? So we are trying to store a sum of credits based on some criteria. When should we make this calculation? When any of these trigger attributes that you list here change in value. So the system kind of monitors these guys, and if it detects a change, then it actually sets our flag field to yes, it's time to recalculate. So I'm going to put in stc.cred and stc.status because that's what I'm summing is the cred. So anytime there's a change in the credits, it's possibly time for me to recalculate. Anytime there's a change in the status of the creds, that is a potential for recalculation. You can load as many of these as you want, as many that make sense. For my purposes, it's just these two. When you get done with the trigger attributes, you're going to click on next, and you're going to be taken to adding entities to the stored computed column. So it put in our file because that's what we're updating. And then it put in student ACAD cred because I just added two trigger fields, stc.cred and stc.status. Those come from student ACAD cred. So it's smart enough to know, like, oh, obviously you need access to student ACAD cred. Are there any other files that you need access to? And in our case, there is. I need access to person ST because that's where my whole query starts. It starts with looking at PST records, grabbing the multi-valued foreign key M2M pointer field that goes to student ACAD cred. From there, we get our credits, evaluate the criteria, and do the whole calculation. So I'm going to right-click in the canvas area and add person ST. Now we need to essentially tell the system, all right, if I'm in student ACAD cred, how does that relate to my custom peer entity F99 person st.cc? So we need to tell the system, how do I go from student ACAD cred to my custom co-file? And so you right click on the field and you can set your target where you're trying to go to, create a link to, put that as F99 person st.cc, and then click on the add and add in stc.personid. So that's a field, a data element in student ACAD cred that holds the colleague ID, which is exactly what the key to our custom co-file is. So that's the relationship. There's a pointer field in student ACAD cred that points directly to colleague IDs, of which our file is one of those. When you return back to the linking entities, you'll find that there's a little arrow saying, okay, I know how to go from student ACAD cred to my custom co-file. I essentially have to rinse and repeat this process for every entity I've listed on this form. So I'm gonna right click on person ST this time. I'm going to add a link. Now I know that these are co-files, so that the key to person ST is the same as the key to my custom co-file. So when I go through this, I'm going to select the entity person ST from the list. I'm going to go through all the attributes till I find, did I back this up? Another little mistake. Oh, I'm sorry. Person ST has the student ACAD cred IDs. That's correct. So I've linked my entities. I've figured out a way to go from student ACAD cred to my custom co-file, and how to go from person ST to my custom co-file. Now comes time to identify the wrapper subroutine and the arguments that you're going to pass into from the system into this wrapper subroutine. So this is why I want you to generate, even though you haven't actually written any code, this is why I want you to generate that subroutine, because when you click browse, you will be able to find your subroutine. If you haven't generated it, it will not be able to find it. Okay, so you're going to select on browse. You're going to pick your custom wrapper subroutine. And remember, on the entry argument list, you had the 3 arguments: a result, AL names, AL values. The names that you select, and you can create whatever you want for those names when you're linking it to the stored computed column. So I came up with x.sum.creds and xl.stc.ids. I could have named them anything I want. That's what's being passed into AL names, is that list: x.sum.creds and xl.stc.ids. What's being passed into AL values is the actual values from the system. Now, the first one is our stored computed column. So that's not going to have anything going in, or it's going to have old data going in. But look at what we're passing in for xl.stc.ids. We're passing in from person ST, the student ACAD cred foreign key M to M Q type pointer data. That's the actual data. Actually, let me go back one more. That's the actual data in that field. We're passing the variables and their values into this subroutine. So the subroutine can make the calculation, and it has everything it needs in order to make the calculation. The last thing to do is to set the recalculation method. I just put this on a separate slide. It's part of the name value pairs and the subroutine. I'm going to leave it inactive because I want to show you something in a little bit. But your other 2 choices are real time or batch. So real time means that when the system detects a change to those triggered elements that you specified, it's going to perform this calculation, which means it's going to jump in and pass the PST student ACAD cred into the subroutine. Subroutine is going to kick off. It's going to do its thing, which sums the appropriate credits, and it's going to populate that stored computed column in real time as it's changing. What batch means is the only thing that will change is the flag field, indicating that it's time to recalculate, but the recalculation hasn't been done. So you can do the batch recalculation by selecting all the records that need a recalc, which means all the flag fields that are set to yes. That's how the batch one works. So when you're done with all of that, you are back on your entity and on the attributes page, and now you have a calculation tab for how this data element is calculated, right? You can go back and edit the calculation, which it'll take you through all the things that I just brought you through: adding trigger elements, adding entities, modifying the links, adding the subroutine, adding the name value pairs, and including changing the recalculation method. So if you click on edit calculation, you can change any of the parameters that you've put in up to this point. And so I changed it to calculating via a batch. I also split out the files here to make it a little bit more readable. In the previous slide, they all kind of get jumbled on top of each other. I just like it when it's, spread out a little bit. Okay, so we're getting close. We've got our entity made, we've got our attribute. We have now provided the system with a method for making the calculation, which when any of these trigger fields change value, it's going to take, it's going to, because I've set it to batch, it's going to set the flag field to yes, that this data needs to be recalculated. But when I recalculate it, it's going to use this subroutine with these arguments and make the calculation. So now we can revisit the wrapper subroutine and do the voodoo we need to do, right? So my values, the second value, I'm going to plug that into xl.stc.ids. Now, here's the important thing, and it can be easily overlooked. xl.stc.ids and x.sum.creds. Those are x.sum.creds and xl.stc.ids. I indicated right here what I wanted to use as variable names in that subroutine. So when I go to write my code, I'm using x.sum.creds and xl.stc.ids. Now, where did I get the value for that? Well, that's in the value pair, AL values. I know it's the second one because, again, you know, that's the value for position 1. That's the values for position 2. So take position 2 and plug it into my xl.stc.ids. Set up a batch process variable so I can easily read the student ACAD cred file. I've got my criteria. If it matches that criteria, then I'm summing the creds into my variable. At the end, I'm setting a.result to my sum creds, and I'm setting the first argument to the sum creds as well. Very simple calculation. You know, depending on what you're trying to do and how complicated that series of computed columns was for you, this could be a much larger subroutine. The subroutine is what is replacing the computed column that was doing the calculation before. Whatever that did, the subroutine has to essentially duplicate that. All right, now it's time to update the stored computed columns. This is done with the form in Colleague called USCC. So I'm in the ST application, and when I bring up USCC, it automatically goes out and looks for stored computed columns, peer entities. So there are 7 of them with mine in there now. So there are 6 delivered. So get rid of the ones you don't want to update. And I only want to update mine. So that's the only one I have left on the list. Now, the very first time you do a recalculation, you'll want to set this force recalculation flag to yes, which means every field, or excuse me, every record will get a calculation. It doesn't pay attention to the flag field. In other words, it kind of ignores whether the flag field is set to yes or no, or isn't even set. It's going to run the calculation. Now, if you have a save list of records you want to process, it'll do that save list. If you leave the save list blank, it'll go against every record, in this case, in person ST. After you've made the initial calculation, and I would do that on a quiet system because it's essentially duplicating that computed column action. Just at the end, you're getting stored data as a result. After that initial first calculation, come back here and do a force recalculation no, keeping the same file, and put it in the process handler to execute nightly, or every week or every month, or however is best suited to the particular calculation you're making. So what will happen is any data element where the flag is set to yes will get recalculated. Data elements where the flag is set to no will not get recalculated because none of the data has changed to warrant a recalculation. So you're going to run this, you're going to run it once initially after everything has been set up to get those calculations in there. All the flags will be set to no, and then you're going to set it up to run again where it only looks for flags set to yes. And that's by saying force recalculation no. All right. You can also update the original query. So we're not going to select against person ST using the computed column. We're going to select against our stored computed column file, and then that particular entity, and then the creds is still the same. You are now working off of stored data instead of having to do those calculations. So it's going to be a monstrous improvement. It's like it was essentially instantaneous, like a few seconds. So all that free time that's not being taken up with running a query, gosh, you can take a nap. You can finish the Sunday crossword, check on that TP supply, wash your hands. Super important. Check the mail, the kind of mail that is walked up to your door. That kind of mail, not the email type. So I appreciate your time spent with me today. I hope that you are all staying safe and healthy. If Ferrilli can help you out during these difficult and challenging times, please let us know. We are available for you and want to help. Have a wonderful afternoon. Thanks for joining me.